We're talking about Chapter 4, Section 4, Triangle Congruence. You can prove something congruent by side, 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 or side, angle, side. Your objective, or what you should know by the end of the lesson, is to apply these two construct triangles and solve their problems. You also need to be able to prove both of these methods of proving triangles congruent. The property of triangle rigidity gives you a shortcut for proving two triangles congruent. And this is your first postulate. One of the ways that you can prove two triangles are congruent is by proving all three of the sides are congruent. So if AB is congruent to FD and BC is congruent to DE and AC is congruent to FE, then I know that the triangles are congruent to each other. Whoops. Alright, so I have your first example, and before we actually do the example, there's a little reminder up at the top that you can use the reflexive property if and only if the triangles share a side. So here's your question. You need to use the side, side, side postulate in order to explain why these two triangles are congruent. I have AD being congruent to CB. I also have DC being congruent to BA. And both of those are given pieces of information because they're marked on my image. I also know, taking a look at my hint, that the reflexive property, if they share a side, I know that that line is congruent to itself. So I have AC being congruent to AC. Reflexive property. And so because of this reflexive property and because of the given information, I just proved that all three sides were congruent to each other on both the triangles. So now I can say that triangle ABC is congruent to triangle CDA. Another vocab word that you need to know is an included angle. An included angle is an angle that is formed by two adjacent sides. So there's my included angle, and these are the two sides that include that angle. Our next postulate, another way that we can prove triangles are congruent, is by the side angle side congruence. And it's a side, an included angle, and the next side being congruent to that same side, the included angle, and the next side. So if those three parts match in that order, then you can say that those two triangles are congruent. And notice that I said in that order. This is the side angle side, or the SAS congruence postulate, not the ASS congruence postulate. If I have an angle and a side congruent, then it doesn't necessarily mean that my triangles are congruent. Alright, here's your next example. You need to prove that these two triangles are congruent. You need to tell me why. So I have side XZ, and if you want to go ahead and pause the video right now, see if you can figure it out on your own, I think that would be a good idea. Otherwise, go ahead and keep watching. So I've got side XZ is congruent to side VZ. XZ is congruent to VZ, and that's given information. I also know that YZ is congruent to WZ. And that's also given information. And I don't have enough information to say that these two lines are the same length, but I do have enough information to say that these two angles are the same measure. And the reason why I can say that is because they are vertical angles, and we talked about vertical angles. So I can say that angle XZY is congruent to angle VZW. And the reason why is because they are vertical angles. So now that I've proven a side, an angle, and another side congruent to each other, I can say that triangle XYZ is congruent to triangle VWZ by using the side, angle, side postulate. Okay, we need to show that these two triangles are congruent and they give us the value of x. X is 5. So I'm going to substitute the number 5 in there for that x. That was easy. If I substitute the value of 5 in here, I get 7. And then if I substitute the value of 5 in here, 3 times 5 gives me 15. 15 minus the 9 gives me 6. Now I can see that side NO is congruent or equal, now I have values, to side QR. I know that NM is equal to QP. And I also know that, let me find another color, MO is equal to RP. So I just proved these two triangles equal to or congruent to each other using side, 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 because all three of them are equal measures. Another example showing that these two are congruent when y is 4. If I substitute the value of y into each one of these, I can check to see if they're equal to each one of those measures. So I have 4 plus 3, which gives me 7, and that matches this one. Over here I have, and I'm going to do this math out there, 2 times 4 plus 3 gives me 8 plus 3, which gives me 11, which matches that. And then my last one, this is the angle T, and I'm going to check to see if it matches angle W right here. So I have 20 times 4 plus 12. I get 80 plus 12, which gives me the 92, and that also matches. So I just proved these two triangles congruent by side, angle, side, because they have two matching sides, and then those two matching sides have an included angle that is also congruent. Postulate. This is the last one. Alright, so given that B, C, and AD are parallel, and I know that they're parallel because they're marked with these little arrows, so that's my given information, and then I also have that B, C, and AD are congruent. Again, they're marked congruent. So I'm going to use my first piece of given information, that BC is parallel to AD, and then I'm going to put given here. That's my reason. And the conclusion that I can draw from that is that angle CBD, this one here, let me use a different color, is congruent to angle ADB, this one here. Angle, and I can say that because this is my transversal that's cutting through my two parallel lines, so alternate interior angles are congruent. Alternate interior angles theorem. And we said that CBD is congruent to angle ADB. Alright, so now that's all the conclusions that I can come up with using that piece of given information. I'm going to use my next piece of given information. BC is congruent to AD, and my reason for that is given. And if you take a look at the information that you have, you can go ahead and conclude that BD and BD is congruent to itself, which I need because I already have a side and an angle. So this gave me my first side here, and that's my angle, so I need the third side. So BD is congruent to itself, BD, and the reason for that is the reflexive property. Of congruence. Alright, so we said we had an angle, which is included. We have both sides also congruent, so I can say that triangle ABD is congruent to triangle CDB because of the side angle side, and I use steps 2, 3, and 4 to do that. Don't forget to write your essential questions and summaries, and we'll talk about this more tomorrow.